board meeting. Let's have a board meeting. I'm saying lots of good stuff. Board. Up. Please. Yeah, I have my kids do this first period too.
All right.
Which is really interesting.
When the red goes on.
Okay. Now, one of the things that we use that's kind of an unusual type of thing, what does the word fast mean?
Opposite of slow.
Depends on, it's relative to something, isn't it? Okay? For example, I was once fast, I am no longer. Okay? And that's, that's not even relative. The fact is, it's hard to say what those things are. But let's talk about speed. You have a change in direction over time. You have a change in average change in position over time. Question I asked several people, what does overtime mean? I used to get paid overtime. Okay? What does overtime mean? Because we talk about wording and vocabulary. What does overtime mean?
During the duration of time. All
right, here's what I want you to think about. Each one of these squares is roughly, let's say, a foot. Most squares are. Now, let's say if each one of these squares is 1 foot, that it takes me 4 seconds to go 4 blocks. Say again? So, 1 second per block, is that what you're saying? So, each second I covered how much? 1 block. Each second I covered 1 block. Suppose that I ate my Wheaties in the morning and covered 8 blocks in 4 seconds. Probably true. Okay? The fact is, in that period of time, I've covered more distance, haven't I? Okay? So in each second, I've covered. What we've done is we've taken per and over, and now we put the time first, haven't we? I want you to think about that. In talking about speed, we talk about distance and we talk about time, don't we? Okay? And distance in this case, I'm going in a straight line, aren't I? Now, suppose that I did this. Suppose in the first second I covered 8 squares, and the second I turned and covered 8 squares. What was my speed on that first part?
Covered 8 blocks in the first second.
Covered 8 blocks in the first second. Very good. What about in the second part?
8 for 8.
It's still the same. Okay? That's a distance, isn't it? Okay? Now, here's a question for you. And this is kind of a tougher one. I come up here 8, and I go over here 8. In what direction am I from my starting point? Here's the starting point. Starting point's right there. That's not 8 and it's not 16, is it? Yeah, you have to do a square root thing here, which is really big. I don't expect you to do that in your head. Okay? If I made it 10 by 10, it'd be 14, I can tell you that. But the point is that this right here we have a special name for. Does anybody know what that special name is? Shortcut is good. Vector's not bad. There's a different term. The term we use for it is displacement. My displacement now has not only an amount of distance, it also has a direction, doesn't it? Is everybody with me on that? So because before I'd only been going in straight lines, hadn't I? In fact, I still did. But.
So yeah, one way of looking at displacement is it's where you the final position relative to the initial position, regardless of the path you took. Okay, so there's a displacement over a given amount of time.
Right. Now, in other words, my average speed here, I took all my squares, which was 16 of them, right? Is everybody with me on that? That's the distance I went, right? And it took 2 seconds, didn't it? So to speak. I mean, that's the idea here. Okay? That's distance and time. That gives me an average speed. An average velocity is a little bit different in that it's really going to be the distance from my starting point to my ending point. That's different from 16, isn't it? Is everybody with me on that? It's the hypotenuse of that, isn't it? Okay? And I could actually, if I wanted to, give it an angle, couldn't I? If I knew a compass direction, I could give it an angle, couldn't I? Or if I said arbitrarily that one direction was 0 degrees, I could do that. That's the direction that we talk about with velocity. Velocity is displacement per unit of time.
If you walked out and turned around and walked back to the same point, would you
good
have a
question.
zero velocity?
Well, let's do this. I came over 8, I came over 8, I came over 8, and I came over 8. That's a total of how many blocks? 8, 8, 8, and 8's 32 blocks. Is that right? Okay. 4 seconds. I could find an average speed, couldn't I? What's my average speed? Well, I'd just do a division there, wouldn't I? Now, where did I end up? What is my displacement?
0.
What is my average velocity?
Whatever that division was.
How far am I from my starting point? Give me a number.
0.
0. My displacement is 0. What then, based on what we talked about as being a definition for velocity, which is displacement per unit of time, what is my displacement? 0. What is my average velocity then? 0.
Okay, so let's be careful with this because this can be confusing. So your average speed was not 0. You're going some speed as you go around this, right? The speed doesn't care about direction. The reason we have an average velocity of 0 is we can talk about velocity in shorter time steps. Between here and here, I do have a non-zero velocity. So I have a velocity that looks like this. It's in this direction. Now it's in this direction. Now it's in this direction, right? Now it's in this direction. If I add up all these arrows, they're going to add up to 0 if I go around this entire circle. That's why you have an average of 0. Any given instant in time, you have a velocity in a particular direction. But if we look at the average over that entire time, it'll average out to 0. I mean, the main message here is velocity is a speed plus a direction. Okay? That's what you really want to take home here. Speed doesn't care about direction. Remember, speed is what's on your speedometer in your car. Your speedometer doesn't care what direction you're going. It's just some number. Velocity is a speed plus a direction. 50 miles an hour north, 15 meters per second southwest. Okay? And so let's talk about acceleration. So what's acceleration? What are our definitions for acceleration? Acceleration is a change in velocity over time. Velocity is speed in a given direction. Okay. Acceleration is a change in velocity over time. Change in velocity over time. Okay. Acceleration is an increase in speed. It's a change in velocity. So that's two different. So no, it's good. This is good. What's great? What's good?
This is good.
If everything was completely, this gives us something to talk about. Acceleration is a change in velocity. Okay. Change in velocity per unit time. Okay. Good. So acceleration is an increase in speed. So how do y'all feel about your answer now that we've had this discussion?
Like Friday.
Let me ask you a question. If I throw this in the air, if I throw this up in the air, okay, what has happened to its speed as it goes up? It slows down, doesn't it? Until what number? 0. Then what happens to it? It falls. Now, in terms of acceleration, as it goes up, it's slowing down, isn't it? Okay? We call that deceleration. We talked about that before. In strict terms, it's still acceleration, though. It's a change in velocity each time period. Okay? It's changing a certain amount of meters per second or feet per second or miles per hour, however you want to do it, in a fairly even amount every time. In terms of gravity, it's either 32 feet per second, or in terms of the metric system, 9.8 meters per second. Okay? In other words, at the end of the first second, if I throw it up at 19.6 meters per second, it's 19.6 minus 9.8 at the end of the first second. At the end of the second second, it's at 0, isn't it? Okay? Now, does gravity stop acting on it up here?
No.
No. It's still there, and it's still the same amount. One of the misconceptions a lot of kids have is that when it gets up here, if I ask them what the acceleration is, they'll say nothing. It's staying still. That's not true, is it?
Well, what do you all think?
Depends on what time frame you're talking about.
Is it accelerating when it hits the top?
That's not giving the snapshot.
We talked about this first.
Yes, but the forces are equal. Yeah, because it's changing direction.
It's changing direct. Well, it's changing. So one way of looking at this is that its velocity. There's nothing special about that point. It's just passing through 0. It's going from positive, getting less and less positive, 0, negative, 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 negative. Okay, so it's your velocity is passing through 0 at that point. Maybe that's not a very clear way of saying it to you, but you're still accelerating right at that point at the top.
All of these things are talking about a change over time, so if there's any change of time at all, there's going to be some change of some sort.
That's right. If its velocity is changing over time, then it's accelerating.
And time is tough to stop.
Yeah.
Would that I could do that at my age, but it ain't happening. Okay?
All right. Should we